The James Webb Space Telescope, JWST, is acknowledged as the leading global observatory used for space research. Its primary mission is to explore the mysteries surrounding both our own solar system and distant exoplanets orbiting far-off stars, as well as to study the intricate structures that compose our universe and where we fit into it. In pioneering work, scientists recently pointed the JWST in the direction of a star 120 light-years away from us. By doing so, the powerful telescope found convincing evidence suggesting the presence of carbon-based molecules in the atmosphere of a conceivable underwater world far beyond Earth. This is awe-inspiring to the astronomy community. But how extraordinary is this possibility? This revelation gives a fascinating look at a planet that is vastly different from anything found within our solar system, while also raising significant concerns regarding the potential for other planets that could be habitable in the vast expanse of space. Join us as we delve deeper into this exoplanet discovery and investigate the captivating information it reveals. If you're eager to keep up with the most recent discoveries regarding the universe and beyond, be sure to subscribe to our channel, like the video, and press the notification bell to stay informed. NASA's James Webb Space Telescope has made a groundbreaking discovery about the exoplanet K218b, a planet that is 8.6 times more massive than Earth. What makes this finding particularly exciting is the identification of specific carbon compounds, such as methane and carbon dioxide, in its atmosphere, detected by the telescope. This adds weight to earlier research suggesting that K218b might have conditions suitable for life. It appears to have a hydrogen-rich atmosphere and a surface covered by oceans. The first analysis of this exoplanet's atmospheric properties inside the habitable zone was conducted using NASA's Hubble Space Telescope, which greatly enhanced our comprehension of the system. It is important to note that K218b is located 120 light-years away from Earth within the constellation Leo and revolves around the cool dwarf star K2-218. This star lies within the habitable zone. Exoplanets like K218b, which fall between the sizes of Earth and Neptune, are a rare category in our solar system because there are no similar planets in our immediate neighborhood. The possibility that K218b could contain a significant amount of carbon and a hydrogen-dominated atmosphere is particularly intriguing to astronomers. Many experts believe such planets may provide ideal circumstances for the search for signs of life. The presence of methane and carbon dioxide, along with the absence of ammonia, reinforces the hypothesis that this exoplanet might contain an ocean beneath its hydrogen-rich atmosphere. Early research has also suggested that a chemical compound, known as dimethyl sulfide, produced by life on Earth, might be detected in K218b's atmosphere. On Earth, most dimethyl sulfide is generated by marine plankton. But the evidence for this compound on K218b remains weak and requires further confirmation. Additional observations using the JWST telescope network should help determine if dimethyl sulfide is indeed present in significant amounts in K218b's atmosphere. One astronomer from Cambridge University explained that although K218b lies within the habitable zone and contains carbon compounds, this does not automatically imply that life can exist there. The planet's radius, which is 2.6 times that of Earth, suggests that it may have a thick, high-pressure mantle of ice, similar to Neptune, with a thinner hydrogen-rich atmosphere and an ocean-covered surface, while liquid water oceans are anticipated. On this exoplanet, there remains the possibility that these oceans might be too rigid or insufficient to preserve life. Despite this, researchers have succeeded in acquiring the most detailed spectrum of a habitable sub-Neptune world at this time, allowing them to identify the atoms that make up its atmosphere. A team member at Cardiff University explained that this challenge was overcome by analyzing light from K218b's host star as it traversed the planet's atmosphere. K218b is classified as a transiting exoplanet. meaning its brightness dims when it crosses in front of its host star. This is how NASA's K2 mission first identified the exoplanet. During these transits, a portion of sunlight passes through the exoplanet's atmosphere before reaching telescopes in space. Like the JWST, which is able to locate lost signals as the sunlight passes through an exoplanet's atmosphere, providing valuable data to identify the gases. The research team plans to use the JWST's mid-infrared spectrometer to conduct additional investigations, confirm their findings, and gather more data about K218b's climatic conditions. Their ultimate goal is to search for signs of life on habitable exoplanets. A breakthrough that could radically change our understanding of the universe. Furthermore, the JWST has made other extraordinary discoveries. Astronomers using the telescope have discovered intricate organic molecules resembling smog or smoke in a distant galaxy. This discovery marks the earliest known detection of such molecules in the universe. Personally, I find this both awe-inspiring and unsettling, as these findings from the farthest reaches of the cosmos are reshaping the very fundamentals of our cosmology. The importance of this discovery lies in the fact that these molecules, known as aromatic hydrocarbons, were found in a galaxy that formed when the universe was only about 10% of its current age. These carbon-based molecules, which are found in petroleum and coal deposits on Earth, as well as in atmospheric pollution like smog, are large and complex, composed of dozens or even hundreds of atoms. What makes this find so remarkable is that such large and complex molecules were formed so quickly after the Big Bang, defying expectations based on our existing models of the cosmos. To put this into perspective, the light detected from this early galaxy began its journey less than 1.5 billion years after the Big Bang, while the universe is currently about 13.8 billion years old. This means we are witnessing some of the first steps in the universe's evolution. The detection of these complex organic molecules, which is the most impressive, was made possible by the Webb Telescope, which will continue to allow us to make similar observations for nearly 1 billion more years. If we could observe even further back in time, could we find even more of these molecules? Perhaps closer to the Big Bang itself. This raises profound questions about our science and understanding of the cosmos. Cosmology. Until now, previous attempts to detect complex organic molecules in ancient galaxies could only confirm their presence. But the Webb's increased resolution can now examine the fine details of where these molecules are located. Additionally, the uneven distribution of these molecules in the early galaxy SP 41847 remains an unsolved mystery. What is truly impressive is that this galaxy was already as vast as our own, containing stars that had generated as much carbon and oxygen as those in the Milky Way, despite being only 1/10 of our galaxy's age. As humanity ventures deeper into the unknown, armed with knowledge and insight, the vastness humbles us, and the complexity of the cosmos with each scientific advancement brings us closer to unraveling the mysteries hidden in the stars as our cosmic exploration network continues to function. It is only a matter of time before the universe reveals more of its secrets, shining even more clearly. Let us know what you think in the comments section. If you enjoyed, make sure to subscribe to the video and activate the alarm clock. As we advance in our understanding of the universe, the James Webb Space Telescope continues to provide us with groundbreaking insights. Its observations are reshaping our perspective on exoplanets and other celestial bodies, pushing the boundaries of what we know about the cosmos. This extraordinary telescope allows us to peer deeper into space than ever before, uncovering mysteries that have long eluded scientists. The discovery of intricate organic molecules in distant galaxies is merely one illustration of how the JWST is transforming our knowledge of the universe's early stages and its ongoing evolution. One of the most fascinating aspects of these findings is the possibility that life, or at least the building blocks of life, may exist in places we once thought inhospitable. The detection of carbon-based compounds in the atmospheres of exoplanets like K218b opens new avenues for studying potential biosignatures on planets that may have some similarities to Earth. These compounds, including methane and carbon dioxide, are frequently associated with biological processes here on Earth. However, their presence on faraway worlds does not confirm that life exists. Instead, it prompts further investigation into the conditions that could support life elsewhere in the universe. NASA's future plans for exoplanet research focus on this possibility. The Internet Telescope's ability to analyze the atmospheres of exoplanets with such precision is a significant leap forward. It allows scientists to detect not just the presence of fundamental elements, but also the complex molecules that might indicate the existence of life. Understanding these details is essential for assessing the potential habitability of distant worlds. As our understanding grows, so too does our ability to detect subtle signs of life, whether it's atmospheric gases, organic molecules, or additional identifiers that could point to biological activity in addition to its work on exoplanets. The JWST is providing valuable insights into the formation and evolution of galaxies. By observing distant galaxies, astronomers can trace the history of star formation, the distribution of elements, and the processes that drive the growth of galaxies. These observations are crucial for understanding the origins of our own galaxy, the Milky Way, and how it has evolved over time. The discovery of aromatic hydrocarbons in a galaxy formed only a fraction of the time ago, when compared to our own, is evidence of how much we are learning about the early universe. As we continue to investigate the cosmos, each new discovery brings us closer to answering some of the most profound questions in science. Are we alone in the universe? What conditions are necessary for life to thrive? How did the universe evolve, and what lies ahead in its future? The James Webb Space Telescope is providing the tools necessary to address these questions, offering a window into the farthest boundaries of space and time. In the coming years, we can expect even more groundbreaking discoveries from the JWST, its ability to study the early universe. Exoplanets and the fundamental processes that shape the cosmos will undoubtedly lead to new insights that challenge our current comprehension. The possibilities for discovering new planets, studying their atmospheres, and uncovering evidence of life beyond Earth are more promising than ever. Each time we observe something, we are reminded of how much there is still to learn about the universe. The Webb Telescope, with its unique capabilities, is leading the way in our pursuit of knowledge. It is more than just a tool for astronomers. It is a symbol of humanity's curiosity and drive to understand the cosmos. As we look to the future, we can be certain that the discoveries made by the JWST will continue to inspire and transform our understanding of the universe, helping us answer questions that have fascinated humans for centuries. As the telescope continues to scan the skies, we can only imagine the incredible breakthroughs yet to come, whether the finding of new exoplanets, the exploration of distant galaxies, or the discovery of life in places we never thought possible. The James Webb Space Telescope is at the forefront of space exploration. Its mission is one of discovery, one that will shape the future of astronomy and our understanding of the universe for generations to come.